Then I would just go into the next one. We don't have
Thank you.
Much time. Then that would be Color in Motion by Marcel from Photoneo.
Hello. Hope you have some energy left. So I would like to speak today about high-quality 3D area scanning for dynamic applications. My name is Marcel Svek. I'm responsible for the product and strategy at Photoneo. Brief introduction of Photoneo. We are coming from Slovakia. We have a headquarters in Bratislava, in Central Europe. We have offices in US and China. And we work with our distributors and partners across the world. And together with them, we installed more than 4,500 solutions already. What kind of solutions? What we do, we provide eyes and intelligence for smart automation. By eyes, we mean a 3D sensor. So this is something that will tell you how the environment, how the scene looks like, but it's not enough. What you need further is some kind of inference, so you need the intelligence, and that's also what we do at Photoneo. And I would say what is our nature as a company is in these two areas. We were kind of trying to be very first on the market, very innovative. So we have our scanner early 5 years ago, and together with the intelligence, so we are already having like one of the most developed robot vision-guided solutions for very demanding beam picking applications and also for very simple tasks. Because there is a different level of problems you are solving, and you need just the right solution for you. So you can come to our booth and see. But what would I like to speak about today is what is, I would say, at the heart of Photoneo, and this is that we always try to bring the innovation in what we do. We did it with the scanner, we did it with the beam picking, but then we really wanted to solve a fundamental problem of the vision and the robotic eyes. And I would like today to show you how we solved it and what do we think is what we can call a perfect 3D vision. So let me speak about 3 key factors of a perfect 3D vision system. So the first one, as you could hear, it's very important that you have a good accuracy and resolution, something that you call a quality. Why? Because you need these properties to do reliable and robust navigation of space. When you want to handle something, you really need to see it, you need to understand it, you need to understand the orientation. Sometimes you need to understand the small detail, because the small detail will tell you the orientation. So high depth accuracy or high quality is really a fundament. The second one is that everything in our world is happening in motion. I'm moving here, and you can see me like I'm moving, right? You don't see just like picture and the picture and the picture. You see me like continuously, right? And you probably see me in high quality. So this is what we think is very important, and that's the ability to scan dynamic scenes, because real-world use cases are happening in motion. So this is really like we figured that machines deserve the same quality of vision, like high quality and in motion, as humans do, And the third one, when you need to take any decision, like I have 2 apples, I want to know which one is good, right? Somebody prefers green, somebody prefers, what is the other color? Red, yeah, thank you. I thought, okay, there are probably no blue apples, So the third property is the color. And why? Because this is needed for the decision making, right? You need to take the decision. So these 3 properties, you can find many systems out there. And you will find one system that is very accurate. Then you will find one system that can scan motion. Then you will find a color cam, right? Something that can give you a color. But you will not find a system, or there was not a system that has these 3 unique properties all together. And this is what we brought together. So these 3 unique properties are now living in one product that I would like to show you today. But first, let me explain a little bit even more and visually what I was trying to say. So imagine you have a random scene. The scene is moving, and you can see there is a wide variety of objects. So there is, I don't know, black rubber, there is something metallic, shiny, there are some plastic, some cardboards, like a random scene. And now my question is, what 3D camera would you use to capture that scene, to see everything nicely, perfectly? What is coming to your mind? Or what kind of technology would you use? So I believe that you already know that there is a technology that is able to scan dynamic scenes, and that's the time of flight. So this is how the data from time of flight look like. So just, this is the scene, and this is what robots get, right? And they need to understand the environment based on that. It's a hard task, right? What you can see here that the resolution is low, the noise is high, and you don't have nice edges. You don't have nice contours. So it's very hard. If you would put your hand on the scene, you would see your fingers blended with the surface and everything. So it's not good enough. So time of flight is very fast, that's perfect, very low latency, but the quality is just not there for making any application. Then we have a sequential structured light sensors, which are perfect for the quality, but they have this fundamental limitation. It's different being fast and able to scan dynamic scene. Why? Because it's the word sequential structured light. You project the sequence of patterns, and when the object moves during that sequence, you broke the code, and this is how the quality looks like. You see a lot of stripes, a lot of artifacts. So basically, you can see there is a round table on the bottom, and it's scanned in nice quality because it didn't change. This is static, but everything that is changing is bad. So structured light systems, based sequential structured light systems, are very good at quality, but they lack the speed. You know, you have just the pictures, you don't have the video. So, and this is what we have in our product, right? This is our product, MotionCam 3D, which won Vision Awards two years ago. And this is the reason why, because it provides both the speed and the quality. And so it's an area snapshot scanner that provides you really nice rendering of the scene in 3D. So this is a normal renderer for now, just so you can compare the quality. So this system is having two unique properties. It is ability to scan dynamic and also has the quality. What is our latest release that we released this year? We added the third fundamental property, so we now have it in color. And this is what we call a perfect 3D vision system. It provides you high-quality 3D data with mapped color. So we say that finally machines can see the world as it is and can do any kind of applications. And I would like to show you these applications to see like what is possible from now on. So one thing that you can do, so you can recognize the objects in real time. And for example, here we are tracking a table tennis balls, and we can recognize them based on their color, but also based on their shell, on their size, diameter. You can see there are snooker balls as well, and we are not tracking those because we know they are smaller, right? So this is the power that robots can do. They can like have instantly the information about where the object is, right? So that's what you need when you want to do any kind of navigation. Then the second one that you can have is that because you are receiving a continuous stream of data, you can merge the scans together. So you would have something like a vision with a memory, right? So basically, like regular vision systems look like I take a photo and I don't know what I saw, you know, like second ago. But this is not true for humans, and it shouldn't be true for vision systems as well. So what we have here, we can create instantly in real time 3D model of the whole scene, so you can see behind. So this is the 3D model created out of it, and this is bringing like so much more robustness into the data that you are having, and you can also see from everywhere. So single perspective scan has always a limitation. I don't know, there is some kind of reflection, there is some kind of artifact, or you need to set it up because of the lighting and stuff. But many times, what is necessary is you just slightly move the position, and all the reflection problems are away, right? So in 1 second, you can move around the scene, create a 3D model, and you solved it. You have a perfect representation of what you need to see. So this is what we call vision system with the memory. So how does the product look like? So if you are familiar with Photoneo, you know our Foxy 3D scanners, you know our MotionCam 3D. Now the latest addition to the portfolio, MotionCam 3D Color is using the same ecosystem, IP65, lightweight carbon body, very high robustness, ambient light suppression. It's based on patented technology that we call parallel structured light. Yeah, so a lot of, come to our booth, you can see all of that. So just for informative, so what are the output formats? So you are getting a point cloud, you are getting the normals information, which is computed directly on the sensor because we have an integrated processing unit on the sensor. You are having a color texture, grayscale texture. We also have a confidence data, which tells you with what accuracy is which point measured. OK, so let me jump to the applications because there is not so much time. So I will walk you through the applications. So first one is that you can do dimensioning. In other words, you need to know dimensions of the object, and that object is moving somehow. And so basically what you do, you synchronize two cameras together, you create a 3D model, and just compute the bounding box. What is the benefit of the system compared to some other systems is that you can have a really large working areas. It has high accuracy because we combine both high accuracy and ability to scan in motion. Yeah, so very practical. It can also be like a void filling, like you need to fill some cushion into the empty box, and you need to know how much cushion should I put inside, right? So you can calculate also, like, you know, not the volume of the object, but what volume is that you are missing to fill in something. Another application is handling of randomly moving objects. You know, so when you have an overhead conveyor, what does the thing do? It moves linearly, right? But then it moves like random. It's swinging, it can be rotating. And basically, there was no other system that can provide you with a good enough data to even try to operate the robot. Now that has changed, and you have a good enough system, finally, to be able to go to the next level of the vision-guided robotics. Another application, so we are hearing a lot about hand-eye, right? Like, just mount the sensor on the robot and do your application. But how does it look like in the reality? You mount the sensor on the robot and you do like scan, then you move, you wait, then you scan, then you move, you wait, then you scan. And if there is something trembling, you got a low quality data. What you can do with MotionCam 3D, you can be just like continually scanning around and understanding the environment. So that's the power of having both quality and speed in one device. And the color is also important for this kind of applications because you need, on this kind of random objects, AI interference. What else can you do? So, for example, this car, it looks like it's going linearly, but you know what this car doing when it's going? It's going like up and down because of the suspension. It never goes straight. It goes a little bit left to right. So here you can combine multiple vision systems, and you can, for example, scan the underbody, stitch the data based on their 3D data, and do an inspection task. This there's a lot of large objects where you need to evaluate their quality, and you need to do that fast. And there were not good enough systems which will give you speed to actually create a 3D models of some objects pretty fast. And here you can basically do that with our system. You can even, like, if you need to be even faster, you can combine multiple systems together, and you can create a 3D model and see the deformation or if there is a rust. Another application where you would need to create a 3D model is when you need to navigate the robot for applications like painting, sandblasting, or any other, we can call it like a trajectory correction. That basically you don't know exact shape of the object, and you need to program the robot to go in a certain distance from that object. So you can create a 3D model, and then you know how far you should be. Another application is, again, inspection in movement. Because we have an area scan that creates a snapshot of the data, even when the doors are like trembling on the conveyor belt, it doesn't matter because you have them in snapshot instantly. So basically remove the trembling, and you can proceed with the standard quality measures. Another thing that you can do is that when something is moving, you can do inspection stuff, and you can pick it, right? After you pick it, what you can do with the object, you can assemble it in motion. And this is actually very like real application that I'm not allowed to show because of the NDA. But this is like when you have multiple systems that needs to operate like synchronously. It's very hard to make them operate perfectly synchronously, right? Because these are like, many times overhead conveyors or different mechanism. And basically, you need some other synchronization mechanism when one robot is placing something into the moving object. So this is, again, where this vision system can be used. Then, more interestingly, now I will move a little bit out from the industry, is that this can be used basically everywhere. It's like a universal vision system, right? It's a fundamental thing. We want to solve the machine vision problem once for all. So, for example, you can do this in virtual reality. They have like in metaverse now, there is a big problem of creating 3D models. So just take the camera and go around the object, create a 3D model, or stream your colleague directly. So this is the quality of the data you are getting from our system. You can also, another application is a teleoperation. For example, in a radioactive environment, you can send a dog in this kind. It's on our booth at Hall 10. Just feel free to visit. There is a dog going around our booth and scanning the environment. So this is where it can be used for. Good. I think I was fast because I think I had a little bit less time, right? Than was, yeah? It's OK. What I would just like to remember is that there was this like understanding of the market that when you are choosing the vision system, it can be only accurate or only fast, or you have some other property. What we like to do is to combine all these unique properties into one device. And this is bringing what we call a paradigm shift. So finally, you can think about your future vision applications differently. And this is what I would like to invite you for. And before the lunch, I would like to also teach you one more thing. And this is how you tell in Slovak, good appetite. So if you will wait for the end of the video, this is how it looks like in our company when there is like, fruits around. It usually takes like 30 seconds to get away. And this is what is it? It's, again, a point cloud from our device. And this is me wishing you a good appetite for your meal. Any questions?
Questions? I think the next group is also ready. In case you have questions, I think Marcel will be happy to take it offline as well. So please join us behind the stage if you have questions. Otherwise, I will leave you now and on to the next session.
Thank you.